This is 9-19, which I think might be one of your homework problems, but it is on the worksheet, so we're going to do it. Determine the velocity v of t and the position y of t of a vehicle that starts from rest at position y of 0 equals 0. And it's basically telling me that this is my acceleration. If you remember, when I take derivatives, I know that if, let's say I call y of t my position, usually they call it s of t, but here it's called y of t, then the derivative of y of t is the velocity. And the v of t equals the derivative of y of t, which is velocity. And I could say that a of t is equal to the derivative of v of t, which is equal to the second derivative of y of t. And this is acceleration. When I integrate, we're going backwards. If I have acceleration, I integrate and I get velocity. When I have velocity, I integrate and get position. The integral of a of t dt is equal to v of t. And the integral of v of t dt is equal to y of t. Basically, derivatives and integrals are inverses of each other. They just do the opposite. I have the integral of 20 t to the third power plus 15t squared plus 10t plus 5 dt. And again, I'm going to do every single thing little by little. Take out the 20, and then I'm using the power rule, which says I add 1 to the exponent and divide by that number. I have t to the fourth over 4 plus 15 times t to the third over 3 plus 10 times t squared over 2 plus 5. And there's really like a t to the 0 power there. So I get 5t. The exponent is 1, so I could divide by 1, but I'm not going to. And then we have plus c, because we don't have bounds on our integral. The next thing I want to do, and this is, I will call v of t, and I'm going to just simplify it. So this is 5t to the fourth plus 5t to the third. Oh, plus 5t squared. That's interesting. Plus 5t plus c. Now we really want to know if we can figure out what c is, because having a c in this equation isn't that helpful. Let's see if there's something we can use. Oh, look, I'm starting from rest. That means that my car is not moving. And if my car is not moving, I can say that v of 0 is equal to 0. I just plug 0 into all my t's. So I have 5 times 0 to the fourth plus 5 times 0 to the third plus, hopefully you know that where this is going, plus 5 times 0 plus c. And this is 0, this is 0, this is 0, this is 0. And now I know that c equals 0. V of t is equal to, everything's a 5. I can just factor out a 5. It might make the next thing easier. Let's see. 5 times t to the fourth plus t to the third plus t squared plus t And we already said my C is equal to 0. It just disappears. And I have my velocity function. But I'm not done because the next part of the problem says, I believe I have to find my position. Determine the velocity v of t and the position y of t. And again, it's telling me now for the next one, y of 0 equals 0. If I want to find y of t, that equals the integral of v of t dt, which is equal to the integral of 5 times t to the 4th plus t to the 3rd plus t squared plus t dt. And then I'm going to take the 5 outside and I'm going to integrate each one of these in here separately using the power rule. I have t to the 5th over 5 plus t to the 4th over 4 plus t to the 3rd over 3 plus t squared over 2 plus c. This is equal to y of t. But again, we want to figure out what c is. And we're being told that y of 0 is equal to 0. I just plug that in for all my t's. And I would end up with 0 to the 5th over 5 plus 0 to the 4th over 4 plus 0 to the 3rd over 3 plus 0 squared over 2 plus c, which means I know now, since this is all 0, I know that 5c equals 0 or c equals 0. So I do know c equals 0, which means that my function y of t is equal to 5 times t to the 5th over 5 plus t to the 4th over 4 plus t cubed over 3 plus t squared over 2. And the c is 0. Now you might get a problem where it says y of 0 equals 1. Then you would have to say c equals 1. But it just so happens for this problem, they're saying that it equals 0, which gets rid of all my constants. That is not always true. Don't make a rule out of it. But this is the final answer for my position. And this is the final answer for my velocity.